Alright guys, here we are with the kids ride-on project I've been working on for the past 7-8 months. It all started whenever the gearbox broke in it. I had already had the idea from when I first bought it because the remote control and everything that came with it was extremely cheap. And when the kids tried to steer, it was connected, the steering wheel was actually connected to the gearbox, the output of it, and it made it extremely difficult to steer. So I've given them completely ripped out the old computer board that was in there and redesigned my own and gave them power steering. So in here we have my actual control box that I designed with my logo, status light telling you that everything's good to go. If something was wrong, it would be red and the kids wouldn't actually be able to drive it. I think I have it where this remote control could still do its thing even if something is wrong. That way you could get it back to your house or get it back somewhere to work on it. Here in the front we have where the 24 volts come in. Then here is where the power comes out for the rear two wheels, the rear and I said that backwards, the rear and the front, and then the steer motor. Here is where the receiver antenna comes out for a signal for the controller whenever you want to take over as a parent. I'll show you in a minute how you activate that. And here are all the sensor wires. Everything's heat shrunk and soldered or connected with really good JTS connectors. Here is the gearbox. I found this gearbox online actually and took a little bit of it and made it my own so it could connect to an old vacuum motor that I had laying around, and it's belt driven up here at the top. I have a cover over it, that way the kids can't get their fingers in it because it actually protrudes out into the front a little bit. Down here I have the magnetic encoder. It's this box right here. I've have it completely waterproofed and I put conformal coating over the top, that way it can't rust as this is exposed to the elements, and it tells the computer where the wheels are actually pointing in a 360-degree circle. I have the limit set 45 degrees left and right now. Up here you can tell the kids can easily turn the steering wheel now. I have it in neutral so it doesn't go anywhere. Can't even go anywhere with the foot pedal. But once you have it in forward, you can actually control the wheels. Left, right, center, and so forth. And you can go forward or reverse. Neutral is a safety, that way when the kids are getting in and out, you don't have to worry about them actually taking off on each other and running someone over or doing something unwanted. We've had Teddy here, been a good sport. He's been helping us test everything to make sure it was good before we put the kids in it. And before y'all call PETA on me, I've had them buckled in, so we're good to go. Like I said, I ripped out the old control box and I plan on open sourcing all this and putting all the files for all the 3D printed parts, the schematic, the code. There's over 3,000 lines of code right now between the two microcontrollers that I have. I want to show y'all real quick how you would actually activate the parental controls. You turn on this remote. It's 25 bucks offline. It's a FlySky FX i6. Everybody uses it for different projects from RC cars to planes and so forth. You hold the down button for 3 seconds. 1, 2, 3. And then now you have control and if you stop putting input in for up to 20 seconds, that's when it gives control back to the kids. I'll show you how fast this thing can go. Pretty cool. Thank y'all for following me, and I'll get back and I want to show y'all here in a little bit the behind the scenes, what it takes to make this happen between the CAD models, the code, and the schematics, and the web server that I've created. Thank y'all. Alright, so as promised, I'm going to show you things that it takes behind the scenes to make the ride-on project work. First, we're going to start off with the schematics for the PCB. So here's where you have to start to get everything lined out and organized. We have power, inputs, our 2 microcontrollers, and outputs. From here, when you have all this laid out not going to bore you with details, but next you'll end up here where you have to make all your traces, which is all your basically tiny wires that go to everywhere, go to all your components. I use Netlist to help make sure that I have all the wires going to the correct components. Basically, I label it on each side, the microcontroller side, or where it's coming from and where it's going to. That way when you start it, all you have to worry about is the path. Then we have code. Since we have two microcontrollers, there are 2 bits of code. This first code is for the ESP32, which it is the one that has built-in Wi-Fi. So it's able to connect to the internet, and I'm able to run everything through it. There's not really a lot that goes into this. Well, I say that, but there's about, as you can see, 1,073 lines of code. On the Teensy, it's a little bit more complex. As you can see, each one of these sections has its own bit of code. This main one is what really runs everything, and we're sitting at 1,397 lines of code, which is quite a bit. Each one of these adds a little bit more. This one has 275, small amount, almost 500, 130 something, so on and so forth. Every bit of this has its own function. I'm not going to bore you with what all of it does. As you can see by the final product, what it actually does. Next, we have CAD. So there's 3 bits that I had to design. One was the steering wheel assembly, as whenever we first bought it, the steering wheel is actually hard coupled all the way to the physical gearbox or the wheels. Well, the way this one's designed, since it's power steering based, is all it has is a bearing and a potentiometer that sits here. So all it's is driven by wire instead of actually direct connected. Next, we have the gearbox. This is a stackable gearbox that I found offline. Each stack that you add adds a 4-to-1 gear ratio, or a 1-to-4 gear ratio. I said that backwards. Because obviously we want more torque out of the output and more speed where the motor sits right here. I didn't model the motor as it wasn't necessary. It's belt driven to this, and then from here, I believe that was a I can't remember the exact gear ratio. I think it was a 1-to-32 gear ratio reduction, and then each one of these stacks, like I said, is 1-to-4. As you can tell by the actual product, I have added, I think, 3 or 4 more stacks to it to get the exact output and torque that I wanted, which it helped because it made it to where you couldn't really back drive that output. Say you're on a hill or something like that and the code tells it to go to a certain angle, it's going to stop. But that angle is not actually going to change due to a bump or something like that. It physically has to be driven by the motor because of how much it's geared, which is a good thing. Next, we have the housing for the PCB. It needed a box to live in to stay, one, weather resistant, and to keep everything in a nice, organized manner. That's where all the wires come out. That's for the antennas for the receiver, the RC receiver. Here's our 2 microcontrollers that just plug in. That's our power supply that takes the 24 volts that come in and turns it into 5 volts to run this, to run all the logic. And then 24 volts comes in here, is fused through that fuse, and comes out here at 24 volts, going to each of these motor drivers. And then from each of the motor drivers, here and here, power out to the actual motors. I have everything labeled in the back so it makes it easy for anybody who were to work on it or anybody wanted to build their own, as I plan to open source this, put it online so other people can take it and run with it and do what they please. But yeah, here we have it. It's not in here, but I had a special mount this is a RGB light that can be any color, and I have it programmed. I put a special attachment for a fiber optic cable that runs up and out the eye right here to give it an added effect. But it's a status light, an indicator light, if you will. But yeah, I hope y'all enjoy, and once I do open source this, I will update this video and add links to where you can find it. So here I want to show y'all the web controller. I know y'all can see my IP address. I may have to blur that out, but this is everything that we have. This is everything that it's showing. We're going to turn auto scroll off because right now it's just scrolling through everything, but I want to be able to show y'all exactly what it's doing. So here is your steering, your raw input for your steering, throttle, steer to, and throttle to. Steer to and throttle to are for the remote control. The encoder is that magnetic encoder I told you about. Then I have this same 5 lines, or actually I have 4 lines. I don't have the encoder on there, but I have them output in a percentage just to make it easier to visualize. And then here we have the percentage for your front left and front right, that's the direction the motor is spinning. So that would be forward and reverse. Forward and reverse. Tells you what percentage it's sending power-wise to the wheels. Right now, obviously, nobody's hitting anything on the actual device, so they're 0. And then here I have the amp draw. That way I could monitor, and the amperage, so each motor driver is rated at 43 amps continuous. They never make it even close. I mean, they have a lot of room for this. I could potentially put more voltage to it, or maybe even a bigger motor one day for the actual drive wheels, make them more powerful, make them faster. Here where it says car, it's either going to say car or remote, depending on who's in control. Once you hold the down button on the receiver for 3 or 4 seconds, like I said, it will swap to remote for while they're in control. And then here you have the loop, which is how fast in milliseconds that it's running through the entire lines, the entire code, basically. I don't exactly remember. Oh, yes. So this T is temperature. Right now it's extremely cold outside, which is why we're sitting at 22 degrees. That's the temperature of the Teensy board. It has an onboard thermometer. So this is everything that it shows over the web. It tells you here if both microcontrollers are connected. It has the version of the code that I'm running. And here it tells you if the rollover protection is disabled or enabled. And it can easily be done with a click of a switch. Here's where you'll drag and drop if you have new code or if you make any updates to either one of the microcontrollers. You literally update it in Arduino, make whatever changes you need, and export it as a compiled binary. And then you take that binary file and you just drag it and drop. And once you drop it in, it does everything by itself. You'll see an uploader bar that will go all the way to 100%, and it will tell you if it was successful or not. And you'll know you can change the version. Every time I would change the code, I would update the version. You have to do that manually. But once you see the new version appear, then you know that your code was actually accepted and is now working on that microcontroller. Yeah.